All right, so this is section 12.2 plus, mole volume relation. All right, so what we want to do is be able to identify the volume of a quantity of gas at what we're going to talk about is STP, standard temperature and pressure, and then also calculate something called the molar mass from the density. Well, I guess we already know that, but all right, so first of all, we've talked about Avogadro and his number, and to be honest, he never actually calculated that number. That's not something he ever did. But what he did do was find out this, that if I have equal volumes of gases, so let's say I took 10 liters of two different kinds of gas, and I had them all at the same pressure and temperature, they would have the same number of particles. That's what Avogadro figured out. So at the same temperature and pressure, equal volumes would have the same number of particles. Kind of an important thing. So it doesn't matter whether we're talking about hydrogen gas or carbon dioxide gas. They're all the same amount of particles. So even though gases are not the same size, because there's so much empty space, it doesn't really matter. So think about if in this room you had a bunch of like 100 ping pong balls bouncing around or 100 baseballs bouncing around, they would still be, in this room bouncing around without any problem. Same thing. Size doesn't really matter, because we don't have that many. There's a lot of empty space in here. The only thing that does matter is pressure and temperature. So pressure and temperature affect the volume of that. So the more pressure I put it under, think about it, it's going to get smaller, right? The more temperature I add to it, it's going to expand if I do that. Okay, we talked about standard temperature and pressure. This is something that you should know, probably write this down. Standard temperature means 0 degrees Celsius, and it's a pressure of 101.3, what's known as kPa, kilopascals. That is the SI term for pressure. The old term was 1 atmosphere. When you listen to the news, you usually hear them talk about like millimeters of mercury or something like that. But we're going to use kilopascals, so that's the one that be familiar with that. 101.3 kilopascals is standard pressure. 0 degrees Celsius or 273 K is our standard pressure or standard temperature. So if I have 1 mole of a gas at STP, I've got 6 times 10 to the 23rd representative particles, and that volume is always, and here's this new number that you need to know, 22.4. So 22.4 is the molar, this is known as the molar volume. Okay? 22.4. All right, so if we want to calculate the moles of gas, all we got to do is take our number of moles by 22.4. That would give me the volume of my gas. So if I had 5 moles, I just take it times 22.4, whatever that would be. All right, so it says determine the number of moles if I have 33.6 liters of hydrogen at STP. So once again, I'm going to do my normal, how many moles? I'm given 33.6 liters. And I'm going to do my conversion. I know that 1 mole equals 22.4 liters. So I can put that in. Put it in so it cancels. 1 mole HE, 22.4 liters. Make sure your things cancel when you're done. Okay? So I don't think these are hard. I mean, I think they're pretty straightforward. You're just worrying about that 22.4. You're either going to divide or you're going to multiply. And once again, if you looked on your mole map, on that mole map, it kind of gives you, all right, am I going to multiply this time? Am I going to divide? So take a look at that map. That should help you out. Okay, next one says, what's the volume of 3.7 moles? So I want to know, volume is liters. How many liters of N2 given 3.7 moles N2? And I know that 22.4 liters is 1 mole. All right, 82.9 liters. All right, one other thing we can do with this is calculate densities. Anybody remember what's our density formula? Yeah, so we're going to go back and we're going to use this again. Density is mass over volume. Usually if we're talking about a gas, we're going to use our density in terms of grams per liter. And you do need to know the temperature because densities of gases change dramatically depending on temperature. So it is important, and most time we'll do it at STP. In this chapter, everything will be STP. So here's the thing. It says molar mass equals density times molar volume. Well, think about if we have our density equals mass over volume, and they're solving for molar mass, that's M. Mass is going to equal density times volume. That's all that sentence says. We just solve for M. All right, so let's do a problem. Density of a gaseous compound of carbon and oxygen is 1.964 grams per liter at STP. Determine its gram formula mass. That'd be the mass. So we know mass is equal to its density, 1.964 grams per liter, times the volume, we just said, 22.4 liters. So calculate that out, and that comes to be... So that comes out to be 44 grams. Okay. Well, the question was, is it carbon dioxide or carbon monoxide? Well, CO2 is 12 plus 2 times 16, or 44, whereas CO is only 28, so it's carbon dioxide. All right. Once again, here's that mole map. And we've now added volume. Remember, this is going to be in liters. And so if we're going from moles to volume, we're going to multiply by 22.4. If we're going the other way, we're going to divide by 22.4. So that's our addition to what we've added in here.